Okay, in this video, I'm going to introduce matrices to you. I'm going to look at adding and subtracting matrices, multiplying, and the identity matrix. So first of all, a matrix. For now, we'll think about matrices as an array of numbers. So we usually use capital letters to represent matrices. So A could be the matrix, let's say 1, 2, 0, 0. And let's make another matrix. B could be the matrix 2, 1. And let's say C is the matrix 0, 0, 0, 0, 0, 1. Okay, so all three of these are matrices. But they do look different, and we have a way of describing the size of a matrix, or we call it the order. And so the order of this matrix is a 2 by 2. So this is a 2 by 2 matrix, and this is because there are 2 rows and 2 columns. So this is a 2 by 1 matrix, and this is a 2 by 3 matrix. Okay, so let's look at adding and subtracting. Now you can only add and subtract among matrices if the order is the same, so if the size is the same. So this is a 2 by 2 matrix, this is a 2 by 2 matrix. You can add and subtract. So let's work out A plus B. So A plus B, but let's write down what the matrices A and B are. So it's 2, 3, minus 1, 0, and minus 3, 4, 1, and minus 2. Now when adding or subtracting matrices, you just add the corresponding elements. So by the way, the numbers inside the matrix are called elements. So this matrix has 4 elements. This is in the first row, first column. This is the element in the first row, second column. If I asked you in this case, what's the element in the second row, first column? Well, second row, first column is clearly the 1. Okay, so let's just do this addition. So 2 add minus 3 is minus 1. 3 add 4 is 7. Minus 1 add 1 is 0. And 0 add minus 2 is minus 2. And it's as easy as that. So let's look at A minus B. So A minus B is equal to, well, still 2, 3, minus 1, 0. And this time we're taking away minus 3, 4, 1, minus 2. Let's do this subtraction. So 2 take away minus 3, which is the same as 2 add 3, which is 5. 3 minus 4, which is minus 1. Minus 1 minus 1, which is 0. And 0 minus minus 2, which is positive 2. Okay. All right, so here in part 3 and 4, what we've got is this is 2a, essentially this is multiplying the matrix A by a scalar, by just a number, and it's exactly how you'd think it would be. So you just multiply all the numbers, all the elements by 2, in this case, so 2a. You could also think of this as A plus A. So if we do A plus A, what will you have? You have double of each element. So this is 2 lots of 2, 3, minus 1, 0, and that's just equal to 4, 6, minus 2, 0. And we can also, and now while we're not doing this in this example, you can also factorize a number out. For example, if I just had this, I could factorize out the 2 and say this is 2 lots of this. Okay, and finally, we want to do 3b minus a. So I'm going to get rid of what we've done. So actually, let's just minimize this. Again, this should be pretty straightforward if you've done it. Well, you've done Fp1 and you've done, and my task, so year 12, you're doing Fp4 right now. So this is just stuff that you shouldn't really need revision, and hopefully, I mean, you can skip this if you're pretty confident what it is. So let's do 3b minus a. So 3b minus a, and that's simply 3 lots of 2, 3, minus 1, 0, that's 3a. I did 3a there. So it's 3 lots of minus 3, 4, 1, minus 2, minus 2, 3, minus 1, 0. And when doing this, you can multiply this all by 3, or you can just do the element by element. So you say 3 times minus 3, minus 2. So what's that? Let's work this out. So 3 times minus 3, minus 9, minus 2 is minus 11. 12 minus 3, which is 9. 3 minus 1, so it's 3 plus 1, so that's 4. And minus 6, take away 0, this is minus 6. Done. Okay, let's move on to multiplying. So multiplying matrices is a little bit trickier. First, when you're multiplying matrices together, we'll do a few examples, but you multiply rows by columns. So actually, we'll do these. We'll look at the examples instead of me just describing it to you without doing an example. Let's just go straight into the example and work out what these things, and hopefully by then you see the pattern and see what I'm doing. So let's work out A times B. By the way, not all of these are possible. I'm not going to work out all 6 of these. Sometimes multiplication between matrices is possible, sometimes it's not. So let's work out AB, if we can. Well, Let's write them side by side. A is the matrix 2, 3, minus 1, 5. And B is the matrix minus 3, 2, 0, 1, 4, minus 2. Okay, so this multiplication is possible. Now, when I multiply this, this is how the procedure I'm going to do. So I'm going to take, actually, probably don't need anything that big, but I'm going to take this row, and actually for now, you don't need to put a circle around it, but just for illustrative purposes, I'll put a circle. You take the first row, and you multiply it by each column. And whenever you multiply by this column, when I say you multiply and add, I'll show you what I mean in a little bit, you get an element. And you get elements in the first row of your answer. And then you're going to move it down to the second row and multiply by each column. And that'll give me my second row in my answer. So let's do it. So 2, so imagine just picking this up and putting that there. So it's going to be 2 times minus 3 plus 3 times 1. So I multiply this times this and this times this. Then I add what I get. So it's 2 times minus 3 is minus 6 plus 3 times 1, which is just 3. So it's minus 6 plus 3, which is minus 3. So I've put that number there. Now I'm done with this column, with this row. Now I'm going to take the same row and I multiply it by this column. So I'm going to do 2 times 2 plus 3 times 4. 2 times 2 is 4. 3 times 4 is 12. So it's 4 plus 12, which is 16. Notice the row here determines the row in the answer. The column here determines the column in the answer. So first row, first column gave me first row, first column in my answer. First row, second column gave me first row, second column. Now I'm going to do first row here times the third column. That's going to give me my first row and third column. So 2 times 0, so is that 0? Yep, 2 times 0 plus 3 times minus 2, that's just minus 6. I'm done with this now. So now I move on to the second row. And let's do this in purple. All right, so you don't need to put these circles. I'm not going to put these, not circle, I'm not going to put these ovals around next time, but just for now, so take this minus 5 and this minus 1 and this 5, and imagine multiplying it. So lifting it up, rotating it, and multiplying it by this, and then we're going to multiply it by these two, then multiply by these two, and multiply and add, of course. So the first one I'm going to do minus 1 times minus 3 plus 5 times 1. So minus 1 times minus 3 is 3. 5 times 1 is 5, so it's 3 plus 5, so that's 8. Do this now. I'm done with this column. I take this row and multiply by the second column. There's minus 1 times 2 plus 5 times 4, so it's minus 2 plus 20, which is 18. And finally, I take this row and multiply by this column, which is minus 5 times 0 plus 5 times minus 2, that's minus 10. And that's it. We're done with the answer. Okay, so let's try now BA. So BA. So we do need to write it AB. We have to write it in the same order. So let's write down B first. It's minus 3. In fact, let's 2, 0, 1, 4, minus 2. I'm going to multiply it by 2, 3, minus 1, 5. Okay, so let's try doing this. So we're going to take this first row and multiply it by this column, and already you see we've got a problem. When I take this row, yeah, I can do minus 3 times 2, 2 times minus 1. Well, what do I do 0 times? Well, there's nothing there. So this multiplication is not possible. You can't do it. So what do we need to match? So just looking, I need the length of the row to match the length of the row in my first matrix to match the length of the column in my second matrix. So in general, let's actually think about this in terms of orders. So if you look at AB, so AB was now we're just looking at the orders, was a 2 by 2 matrix multiplied by a 2 by 3 matrix. And these are the numbers we're interested in terms of can we multiply matrices together. So because this 2 tells me I have 2 columns, essentially that's telling me how long the row is. And this 2 is telling me I have 2 rows in my second matrix. So by the way, this is for A, this is for B. So it's a 2 by 2 A. This is a 2 by 3. So I've got 2 columns and I've got 2 rows here. So 2 columns and 2 rows. These numbers match, so I can multiply. And my final answer, remember I said for each row here, I get a row in my answer. So I've got 2 rows in my first matrix, so I'll get 2 rows in my answer. I've got 3 columns in my second matrix, so I'm going to get 3. So I said, when doing this, so and let's just check, this is a 2 by 3 matrix. So in general, for matrix multiplication to be possible, let's take any general matrices M, A and B. No, let's not. We're already using A. Actually, let's just use it. So if A and B is possible, let's say A was an N by M matrix, and B was a P by Q matrix. For this matrix multiplication to be possible, and I put a middle one in there. We don't need that time, but for this matrix multiplication to be possible, these two must be equal. So M and P must be equal, right? So in this case, as here, they're equal. And your final answer here will be an N by Q matrix. So these have to be equal. So in this case, let's see what we have. We've got a 2 by 3 matrix multiplied by a 2 by 2 matrix. And you see the number of columns here, or my row length, or my number, which is the same as the number of columns, does not match my number of rows or my column length. These numbers don't match. Matrix multiplication, not possible. All right. So we've done AB and BA. So let's look at BC, CB, AC, and CA. So I'm going to do these a little bit quicker now. I explained this theory. So just, you can try these on your own. If you've forgotten how to do these, or drew at least a few of these, at least make sure you should be able to tell just in your head which are possible, which aren't possible. So BC, so it's this times this. So it's a, and before we even do this, let's just check if it's possible. Well, B is a 2 by 3 matrix. Let's just look at it. So 2 by 3. And C is a 3 by 2. Numbers match. So we can work out the answer. And let's just work out. So my answer should be a 2 by 2 matrix. Okay, so let's actually work this out now. So it is possible. By the way, as we saw in my previous example, when I worked out AB, BA we couldn't even work out. So in general, matrix multiplication, AB and BA are not equal. And this was a clear example. AB existed, BA didn't even exist. So this called commutativity, matrix multiplication is not generally commutative, which means you can't just switch the order. Multiplication, we know in normal numbers, is 3 times. Let's say if I did 4 times 6, that's exactly the same as 6 times 4, but not with matrices. Okay, so let's work out what this, I don't need this now. I know it's possible. I know I should get a square matrix of order 2 by 2. Let's just do this. I'm going to do this. I want to speed up a little bit now. This video is getting a little bit too long. So it's 3 minus 3, 2, 0, 1, 4, minus 2, multiplied by C, which is this. So it's 1, minus 1, 0, 3, 2, 4. Multiply this yourself now. Check if you get the right. Just pause and then see if you check that you've got the right answer. So I'm going to work this out now. So take this first row, multiply by this first column. So it's minus 3 times 1, and then the 2 times 0 and the 0 times the 2. So those don't give me anything because it just gives 0 and 0. So it's minus 3 times 1, which is just minus 3. Now I'm still first row. Now I'm going to multiply by the second column. Minus 3 times minus 1, which is positive 3. 2 times 3 equals 6. So 3 plus 6, which is 9. And then the 0 times 4 doesn't give me anything. So this is 9. I'm done with this first row. Now we move on to the second row. So it's a 1. By the way, I didn't need to make this so long because we already know what it should be. It should be a 2 by 2 matrix. So let's just trim it down a little bit. So it's this row now. So it's 1 times 1, 4 times 0, minus 2 times 2. So imagine, still, if you're not comfortable with this, imagine just picking up this row and then plonking it down here. So it'd be like and I put them in faint now. If you still don't know what I'm talking about, so it'd be like a 1, a 4, and a minus 2. And then you do the multiplication. And then you add. Okay, so we're not going to bother doing that. We're just going to do it in our head. So 1 times 1 is 1. 4 times 0 is nothing. Minus 2 times 4 is minus 4. So it's 1 minus 4. And 1 minus 4 is minus 3. Yeah. Okay, now this row by this column. So it's minus 1 plus 12, which is 11. 11 minus 8, which is 11 minus 8 is 3. So I'm just going to double check my answers that I've got that. So let's see, minus 3. Okay, so I got that right. Excellent. Okay, so that's that. Let's look at 4CB. Well, so let's work out if we could do C times B. Well, C is a 3 by 2. B is a 2 by 3. Match, so we can work it out. And our answer is going to be a 3 by 3. So this one's going to be quite big, this one. Okay, so let's do this. I'm going to get rid of BC, because this is a video. You shouldn't need it anymore. You can just pause if you needed that answer. Obviously, just pause. So we should get a 3 by 3 matrix when we do CB. Okay, so let's write these down. So C, B, and C was a 1, minus 1, 0, 3, 2, 4, and a B is minus 3, 2, 0, 1, 4, and minus 2. By the way, we already know this isn't going to be the same as BC. BC was a 2 by 2 matrix. CB, we've already seen, is going to be a 3 by 3 matrix. So the answer, again, we see BC and CB aren't equal. So let's work this out. I'm going to do this a little bit quicker now. So this row times this, so it's 1 times minus 3, which is minus 3, plus minus 3 minus 1, which is minus 4. Times that, so it's 2 minus 4, which is minus 2. And then plus 2. That down to the second row now. So 0, okay, that's just 3. And because it's 0, my life is now going to be 0, really easy, just because it's going to be 0 times all of that. So it's just 3, and then this times this, which is just 4, then this times this, which is just minus 6. Okay, now we're down to the 2, 4 multiplied by each column. So that's minus 6 times minus 6 plus 4, which is minus 2. And then it's just 4 plus 16, which is 20. And minus 8. All right, so that should be our answer. I'm going to check. By the way, I'm following along with the examples and integrals. If you want to have a look, just look at what I did there previously. And that looks... Wait, did I make a mistake? Minus 4, minus 2, 2, 3. I did make a mistake. In fact, I think this element is a mistake. So how do I work this one out? So this is my... Let's just go back. So this is my second row, second column. So it should be this times this. Yeah, I did make a mistake. I did. It's 3 times 4. I didn't do 3 times 4. I just wrote down a 4. So 3 times 4, of course, is not 4. 3 times 4 is 12. So try doing. So don't make mistakes as I did. If you're in doubt, just do it a little bit slower, and everything else is correct. Okay, so that was 4. So that was CB. Let's go into now finally AC and CA. Okay. So I'm going to get rid of this. Let's just see if it's possible. Hopefully some of these aren't possible, so I don't have to work out all of these. So A is a 2 by 2. In fact, let's just write these down. I keep on. This is a 2 by 3, and this is a 3 by 2. 3 by 2, 2 by 3. Okay, so we're working out AC. Well, A, C. Let's just check. Is it 2 by 2 multiplied by A, and C is a 3 by 2. Well, my number of columns doesn't match my number of rows in the second matrix, so we know this one doesn't work. So it doesn't exist. It's not equal to 0. It just doesn't exist. You can't actually multiply them together. So that's done. So 5 is done. Doesn't exist. And let's go into now CA. Probably I'm going to have to work this one out. Yeah. So it's a 3 by 2 by a 2 by 2. Yeah, it works. So if you didn't see that, so C is a 3 by 2. A is a 2 by 2. It works, and my answer should be, of course, a 3 by 2 matrix. All right. Let's work these out. And so this is the last, I think, one of the last multiplications we're doing. So we'll see that identity soon, and I think that might require multiplication, but let's work this out. So C, 1, minus 1, 0, 3, 2, 4. A is a 2, 3, minus 1, 5. Let's work this out. So see if you can, actually, if you can do it in real time, see if you can do it faster than I'm doing it. So let's start now. So 2 plus 1. Actually, I won't read it out loud either. I'll just write the numbers out. So if you're already started, start now. Okay, now there's pressure, and I'm actually going to be probably quite slow. 3 minus 5 is 1, 2. I'm embarrassed now. You probably finished before me. I was very slow. Again, I haven't said much today. All right, so let's just, hopefully at least I got it right. So 2 times 3 is 6. Okay, so let's just check. Again, we can check the nodes are integral. 3 minus 2 minus 3, 15, 0, 27. At least it's correct. Okay, that's that. Moving on. Okay, the identity matrix, very important matrix. Of course, we see lots of this in Fp4. An identity matrix is a 2 by 2. Well, this is a 2 by 2 identity matrix. An identity matrix can be of any size. You can have a 3 by 3, a 4 by 4, and so on. Identity matrix is just, it works like the number 1. It's a matrix which has the elements 1 in your diagonal and 0s everywhere else. And look, it works like the number 1 because if I do an identity matrix, so looking at here, I times it by matrix A, where A is any matrix that actually which is a 2 by 2, so you can actually do the multiplication. So if I do I times A, and I do A times I get A. So notice it's like the number 1. It doesn't change anything. It's called identity. So this is the 2 by 2 identity, of course. So a 3 by 3 identity matrix will be like this: 1, 1, 1, 0s everywhere else. So 1's in your diagonals, 0s everywhere else. 4 by 4. In fact, 1, 0, 0, 0, 0, 1. Let's just do it neat. 0, 0, 1, 0, and then 0, 0, 0, 1. That's a 4 by 4 identity matrix. Notice that identity matrix is always square. So it works like the number 1. It's also, we use the letter I to represent it. I. That's not a number 1. That's an I. Okay. And finally, example 3. A is the matrix 2, 3, minus 1, 5. And find the matrix B such that AB equals I. Okay, so essentially what we're looking for its inverse. We're looking for a number so that when you multiply it by it, you get 1. So if we were just working with numbers, we know what that is. So if I told you 2 times something is 1, well, you know that's a half. If I told you x times something is 1, well, that's 1 over x. Essentially, we're looking for the inverse of this matrix. In FP4, we learn a quick way of doing this, but we don't know that method now, so this is going to take a little bit of time to work this out. So let's just write down the matrix A. So it's 2, 3, minus 1, 5. Now, we don't know what the matrix B is. So and we want to work out what it is. So we know it has to be square, because we know when we're multiplying it, we get I. Remember I, so this is A, this is B. I is this. So just think about this. This is a 2 by 2 matrix times something. Let's just imagine we didn't know what this was. And this gives me the answer as a 2 by 2 matrix. Well, first of all, for this to work, these two numbers have to match. It has to have 2 rows. And of course, my answer is a 2 by 2 matrix because it has to have 2 columns as well. Okay, so we know, my brackets are the right size. Well, my braces or bracket, I think brackets work. Okay, so now we don't know what these things are inside. So let's just call them A, B, C, D. So the rest of it, what we're going to do now, we're going to multiply these out. Even though we don't know what these things are, these are some unknown elements. We're going to multiply it out. And then we're going to say, okay, then we're going to equate it to these things here. So let's multiply these things. Let's multiply the left-hand side out. So it's 2 times A. So my first element is 2 times A plus 3 times C. So it's 2A plus 3C. Now I'm going to take this and multiply by the second column. So it's 2B plus 3D. Now working down to the second row. Times that, so it's minus A plus 5C. And now this times this, so it's minus B plus 5D. And that's still equal to, so I've worked this out, that's still equal to the identity matrix, so 1, 0, 0, 1. Okay, now for two matrices to be equal, their elements have to be exactly the same and exactly the same place. So this has to be equal to 1. This has to be equal to 0. This has to be equal to 0. This has to be equal to 1. So let's write that down. So I know 2A plus 3C is equal to 1. And I know 2A plus 3C is equal to 1. I know 2B plus 3D is equal to 0. I know minus A plus 5C is equal to 0. And I know minus B plus 5D is equal to 1. Notice, now I've written them like this for a certain reason. It's not just because they're there and they're there. Because if I look at these now, these are simultaneous equations. These are two equations in A and C. That's not a B, by the way. That is a 5. So two equations in A and C. Two equations, two unknowns. I can solve this. Again, B and D. So if you have them mixed up, if you had this equation with that equation, this equation with that equation, okay, just pair them up so that you have the A's and C's together to make one pair of simultaneous equation, and your B's and D's together to make the other pair. So now we just need to solve these simultaneous equations and we'll be done. So let's just deal with this first. What makes it easiest to eliminate? So I'm going to eliminate the A's. So I'm going to do this plus 2 lots of this, which should cancel out. So I get 0 here. So I've got 3 plus 10c, so I get 13c is equal to, well, still 1. So c is equal to 1 over 13. And now let's just work out what a is. So let's plug this into one of these. So by the way, just because I got fractions doesn't mean it's wrong. Of course, don't use decimals here. You don't want to do 1 over 13 as a decimal. It makes life a lot more difficult. So, of course, this rearranges to give me a is equal to 5c. c is equal to 1 over 13. So a is equal to 5 over 13. All right, so we've got a, we've got c. Let's work out b and d now. And we'll do this in, let's do this in black. We haven't used black today. All right, so I'm going to do the same process actually. I'm going to do this plus 2 lots of this. I'm going to eliminate the b. So this, add 2 lots of this. So multiply this whole thing by 2. So 2b, so it's going to be 2b minus, plus minus 2b, so that's 0. 3 plus 10d, which is 13d. And what else? 0 plus 2 lots of this. So this time it's equal to 2. It's not equal to 1. All right, so that gives me d is equal to 2 over 13. And let's plug it in. Let's think about it here. What gives me b? Well, let's use this. Yeah, let's use. Which one should we use? Let's use this one. No, it doesn't really matter. Yeah, actually, let's use it. This one's easy. Let's use the top one. It's easier to use. You don't have to take away or add. This one, if you use this one, you don't have to take away or add. I think. Move that. You have to take away 1. So let's do with this one. Plug d into here. So 2b is equal to 6 over 13. So b is equal to minus 3 over 13. So what I've done was I've plugged this in here. Then I multiply it by 3. That gives me 6 over 13. So 2b is equal to minus 6 over 13. So 1b is equal to minus 3 over 13. Okay, so now we've worked out what a, b, c, d are. So let's put them back into the matrix. So my matrix, what was that? What do we call it? We call it A. No, it's B. So matrix B is, and notice we went A, B, C, D. So let's just put it. So we had A, B, C, D. So I'm doing this just so that I put them in the right place. We've done all the hard work. Now we just need to put them in the right place. So B is A, B, C, D. Okay, so B is actually equal to, well, A was 5 over 13. B was minus 3 over 13. C is 1 over 13, and D is 2 over 13. Now you can leave it like that, that's fine. This is what B is equal to, but I might, instead of having all these fractions here, we can take out a factor. All of these have 1 over 13 in them. We'll take out a 1 over 13. So B, you can also write it as 1 over 13, 5 minus 3, 1, and 2. Okay, that's it. All right, so this is pretty straightforward. You do get a 1 or 2 mark question where you just have to practice this. Make sure you can do this. Make sure you can multiply matrices together. It's very important you can do that. If you make mistakes there, you're going to lose loads of marks. You're going to lose marks with the matrix transformations, definitely. Well, some of those marks anyway. All right, so go away, try some questions on this if you can find some. There are questions on integral on this. All right, so let's just and that's. So before we go, so this is the whole answer. All right, so that's it for now.